Now, before we talk about another theorem about sets called the Morgan's laws, there's some terminology we need to hit. I don't think that I have defined the complement of a set. The complement of a set X is everything that's not an X. So if you were making a Venn diagram, it would simply be the entire rectangle, the entire universe for this problem, minus the set X. So the Venn diagram doesn't need two circles. This is the universe. That's the set X, the circle. Well, X complement is everything in the universe except for that circle. Okay, given that, now I can state the two De Morgan's laws. Given sets A and B in some universe, the universal set U, we have A union B, the complement of that set. It's not what you might hope. It's not A complement union B complement. It's A complement, flip that upside down into an intersection, B complement. That's the first law. And the second law is reverse the unions and intersections. So A intersection B, if you take the intersection, the complement of the intersection, it gives you the union of the individual complements. You could easily prove this using a Venn diagram, and maybe I will. Maybe I'll prove just by using a Venn diagram. I don't know if I want to call it a proof or just I'm showing it to be true, we'll say. It's not a formal written out proof. There's A, there's B. Okay, well, in my scratch paper, I want to write out what A intersection B is. Oops. A intersection B is that football shape. It's the only region in this whole universal set where you're in both A and B at the same time. The complement of that is everything except the football region. So here, everything except that football region. Now, independently, let's look at this one. A and B. It's A complement, union B complement. So I need to shade everything that's in either one of them. So I should shade this one, and I also have to shade that one. So I'll shade A complement first. That's everything outside of the circle or the set A. Or I need to shade this as well, B complement, which would be everything outside the B circle. So that covers this part of A. So notice, using Venn diagrams, we've shown that this is equal to that. And you could do similarly with this. And I think I should have done that one, it looks easier. In both cases, A union B is shading in the entire figure 8. The complement of that is everything outside of the figure 8. And you can see the region we shaded is explicitly defined by you're in not A, the complement of A, and you're in the complement of B. It means you're not in A and you're not in B. That's exactly this region. All right, now let's compare this to theorem 0.3 that we looked at. I'm going to use a different color. All right, remember what the complement of A union B is. Another way of writing that is it's the entire universe minus A union B. That's the complement of A union B. Equals, well, this is U minus A, the universe minus A, intersected with B minus A. I think if you'll compare that to 0.3, theorem 0.3, you'll see they're very similar. And likewise, the complement of A intersection B is the universal set minus A intersect B is equal to the complement of A is U minus A, universe minus A, union, universe minus B. And I think you'll see these two look very, very similar to our previous theorem. So De Morgan's law is something that might simplify your life. So make sure you remember De Morgan's law.